Hi friends, welcome to the series of organic chemistry lectures. Dear friends, today we are going to learn about electrophilic addition reactions of alkenes. Under electrophilic addition reactions of alkenes, today we are going to learn in detail about addition of hydrogen halide, that is HX. It is HCl, HBr and HI. What is the reactivity order of these hydrogen halides? Hydrogen iodide is more reactive than hydrogen bromide, then hydrogen chloride. This is the reactivity order. So let us discuss in detail with mechanism by taking HBr. Addition of HBr to symmetrical alkene. Let us take one example of CH2 plus hydrogen and bromine. Dear friends, I have given a generalized electrophilic addition reaction of alkenes. This is an alkene, ethylene, this is ethylene. When added to a reagent which is consisting of electrophile and a nucleophile. So addition of electrophile, since all these reactions are electrophilic addition reactions, so alkene first adds to electrophile. This is electrophile and gives rise to a carbocation. This carbocation adds with nucleophile to give the product. Right friends? So this addition is trans to each other. Electrophile and nucleophile trans to each other. This trans mechanism is already I have explained with respect to bromine, Br2. By taking bromine, bromination of alkenes is a trans addition. Now, so with respect to electrophile and nucleophile in HBr, what is the electrophile? This is electrophile. This is going to be nucleophile. Right? It is better. You can understand very easily. So CH2, HBr. Now what is going to happen, or what is the product? CH2, I am writing here hydrogen, here bromine. Right friends? This is how hydrogen bromide addition of HBr takes place. What is the mechanism? Let us discuss mechanism. So similar to, right? So since we are taking HBr is nothing but HBr, H plus Br minus, isn't it? Electrolytic fission takes place to give H plus ion and bromine minus, Br minus. So this H plus ion adds first with this alkene to give this intermediate where hydrogen is added here. Right friends? So this is the carbocation. This carbocation with hydrogen gives a carbocation with hydrogen forms protonium ion, cyclic protonium ion. This is cyclic protonium ion intermediate. Cyclic protonium ion intermediate. It is similar to our bromonium ion. Now what happens? What is left over? Here we have bromine, Br minus in the reaction mixture. This bromine comes and adds to here, and this takes up here to give. This is the trans addition product. This is the mechanism of addition of hydrogen halide. Yes friends? So this is hydrogen halide addition. Let us take another example. This is symmetric, means to the alkene both sides CH2CH. It is symmetric alkene. Symmetric alkene. It is symmetric alkene. Right? So symmetric alkene, whether bromine and hydrogen both way, yes. Even if it adds to this side H and CH2 bromine, both the compounds are same. Ethyl bromide, isn't it? Both are same. But when we take unsymmetrical alkene, this is with respect to symmetric alkene. Let us take unsymmetrical alkene. If you take unsymmetrical alkene, what happens? Let us see. Unsymmetrical alkene, for example, if I take propene, one propene, CH3, CH, double bond, CH2, yes, if I add plus HBr, What are the products expected? Yes, CH3, CH, CH2, right? So bromine may add here or bromine may add here, right? So let us take this plus it is expected that you may say yes, why not this? CH, H plus, CH2, Br. So you may say these two compounds are possible, right? These two compounds are possible, but this is the product which is going to form major. This is the product which is going to form major or principal product. It is going to be principal product or major product. Major product. What is the major product? 2-bromopropane. It is not going to be formed, or even it is forms very minor quantities. So what is the principle? This 2-bromopropane, selective formation of this 2-bromopropane is explained by Markovnikov. This compound is also known as Markovnikov's addition product. Markovnikov's product. As per Markovnikov's rule, so during the electrophilic addition reaction, the nucleophile or the negative addendum adds to the carbon which is having highly substituted carbon, or the carbon which is having less number of hydrogens will be added. Dear friends, this selective formation of 2-bromopropane can be explained by Markovnikov's rule. Markovnikov's rule states that the negative addendum, the which is going to be addendum here, which is negative addendum bromine, adds to the carbon having less number of hydrogens. So in any given reaction, in any given compound, the negative addendum of electrophilic addition reaction, during the electrophilic addition reaction of alkenes, the negative addendum will be added to the carbon which is having less number of hydrogens or which is highly substituted. Here among these three carbons, which is less substituted hydrogen carbon, this is the carbon which is having less number of hydrogens. So as per Markovnikov's rule, we are going to get exclusively 2-bromopropane. So let us prove why it forms exclusively this compound only. Let us see the mechanism. When you understand the mechanism, it will be easy to understand. Yes, H, Br. Yes, this is H plus, this is Br minus. So this takes a proton, right? So it may form two types, or it may give two carbocations, CH3, CH, carbocation, CH2, hydrogen here. This is what is the carbocation? Here bromine minus, yes, obviously it will be here. So what is the carbocation here? This is secondary carbocation, So where this hydrogen is an electrophile. First electrophile adds to alkene to give secondary carbocation. This is secondary carbocation. Why? This carbon is attached to two carbon, so it is known as secondary carbocation. So what else other? If this hydrogen adds to here, let us see what happens. CH3, CH, hydrogen is added here, CH2, positive plus bromonium ion, right? Bromine ion. So what is the carbocation here? This is a primary carbocation. So I have explained already stability of carbocations among secondary and primary carbocation, which is more stable. Secondary carbocation is more stable. So this more stable carbocation form will be formed in a major amount, or it forms very easily because the secondary carbocation is more stable. So the formed secondary carbocation easily takes up this bromonium ion and gives our Markovnikov's product, right? Markovnikov's product. Which is the Markovnikov's product? This is the Markovnikov's product, where 2-bromopropane is formed. 2-bromopropane propene, CH3 CH bromine, right? CH2 hydrogen. It will be formed in a major amount. This is Markovnikov's product, whereas this usually it will not form. Even if it forms, it will be less amount. It is going to form this product, which is anti-Markovnikov's product. So as per Markovnikov's rules, it is a generalized rule which was stated in during 1869. He was a Russian scientist, chemist. So he stated that during the electrophilic addition of alkenes, yes, the negative addendum of electrophilic addition reaction will be added to the carbon which is having less number of hydrogens. He stated, he has given one generalized rule. As per his rule, we will get Markovnikov's product, Markovnikov's addition product. This concept is very, very important throughout your chemistry life. So please remember this Markovnikov's rule, where we will get this secondary. This is 2-bromopropene. When it comes to this, let us take another example. I am taking unsymmetrical alkene CH3 CH double bond CH. Here I am going to take phenyl ring. So what could be the product? And I am going to add HBr, right? So what is the product? What do you say? What are the product expected here? Yes, CH3 CH Br CH2. I can write phenyl here, right? This is phenyl ring. Plus, you may say this is also possible, CH3 CH2 CH bromine and phenyl, right friends? So these are the two products expected from this reaction, right? So it is an unsymmetrical starting material. When it is added to, yes, methyl styrene, this is nothing but methyl styrene, right? So when it is added to HBr, what is going to happen? This double bond may give this addition product. Yes friends, among these two, which one is going to be major? Just think, let us see the mechanism. So when HBr is going to be added, Br minus H plus, let us take two possibilities. What are the two possibilities? Yes, CH3 CH phenyl I will write. This is phenyl, or I can write in another form. In next lesson we will learn about aromatic compounds, right? What is resonance and everything I will explain there, right? This is the compound where carbocation can be formed here, and first let us take this is going to be attached to here, right? What is the carbocation here? This is secondary. Before that it is a benzylic, very, very important friends. So benzylic secondary carbocation, benzylic secondary carbocation is formed if hydrogen adds to this carbon, plus, or it may give CH3 CH. I am adding hydrogen here, right? So phenyl here, right friends? So what is the carbocation here? This is this the benzylic carbocation? No, it is only a secondary carbocation. Secondary carbocation. Why it is benzylic? Because it is attached to benzene ring, so it is also known as benzylic carbocation. So benzylic. Why it is secondary? Because it is attached to two carbons. It is secondary benzylic and secondary carbocation. It is only secondary carbocation. Among benzylic secondary carbocation and secondary carbocation, which is more stable? Yes, benzylic secondary carbocation is more stable. This is more stable. So more formation will take place this benzylic secondary carbocation, where this easily takes up and gives this bromo compound, where this easily takes up bromine, right? So this bromine will be added here and going to give, this is the major product. So this is going to be major product, dear friends. So if you know the mechanism, then only you can explain the major formation of this product, right friends? Yes. So important point here to remember is benzylic secondary carbocation is more stable than secondary carbocation. Next, so you may ask why this benzylic secondary carbocation is more stable? Because of resonance stabilization of benzene. Because of resonance stabilization. Why this is? It can share this double bond, right? So this is resonance stabilization. Yes, friends, it will be explained in next chapter. So this benzylic secondary carbocation is more stable because of resonance stabilization of benzene ring. That is why this benzylic secondary carbocation is more stable. So this will be formed in a major amount. So we are going to get this compound in a major amount. This is how. So addition of hydrogen halide. I have taken HBr. Yes, the same mechanism holds good to HI, HBr and HCl. When you compare the reactivity order, hydrogen iodide is more reactive than hydrogen bromide, and this is more reactive than hydrogen chloride. So when hydrogen bromide is added to symmetric alkene, where this is CH2 and CH2, both sides symmetric. So whether hydrogen and bromine, either of the two carbons, doesn't matter, wherever it adds, it is going to give the same compound, that is bromoethane. But when it comes to unsymmetrical alkene, it is going to give, it is unsymmetrical alkene. So here comes Markovnikov's rule. So it is very important. Markovnikov's rule states that the incoming negative addendum which is going to be added will be added to the carbon which is having less number of hydrogens. So among these three carbons, this carbon is having less number of hydrogens. So that negative addendum will be added to the carbon of this to give, this is the major product of 2-bromopropane, right? When it comes to this unsymmetrical alkene, where I have replaced this hydrogen with phenyl ring, so both way it is going to give this bromo or here bromo, right? But among these two, which is going to be found major? This is going to be found major because the benzylic secondary carbocation is more stable than secondary carbocation, which is less stable than this benzylic carbocation. That is why this product is going to be formed major, right? So bromine is going to be formed or attacked at benzylic position. Why this is more stable? Because of resonance stabilization of benzene ring. Dear friends, so this is the Markovnikov's product, but I may be in need of anti-Markovnikov's product, where I am exclusively in need of this product CH3, where I have given CH2 Br. If I am in need of this compound or bromopropane, this is 2-bromopropane, if I am in need of 1-bromopropane from this alkene, what should I do? Yes, there is a reaction or there is a effect which is known as Kharash effect, which is going to be holds good for only HBr reaction. Dear friends, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button.